Alright guys, this is a supplement to the trig notes that we've done so far. And first thing I want to do is recap. We've talked so far about sine, cosine, and tangent, right? Sine we said is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Those are your basic three trig functions. There are, however, three other ones, and they kind of go hand in hand with each of these sine, cosine, and tangent ones. And they are this. There is cosecant, secant, and cotangent. Okay? And I write them like this because cosecant matches up with sine, secant kind of matches up with cosine, and cotangent matches up with tangent. Yes, I know it doesn't make sense that secant goes with cosecant, secant goes with cosine and cosecant goes with sine. I know it feels like it should be flipped, but it's not. This is what math has given us, so we roll with it. Here's why I say they match up, though. In the same way that sine relates two sides being opposite in hypotenuse, cosecant relates two sides as well. It's just flipped. So it's hypotenuse over opposite. Secant is just your cosine relationship flipped upside down as well. So it's hypotenuse over adjacent. And then cotangent is tangent flipped. So it's adjacent over opposite. And these three functions all have abbreviations. Cosecant we abbreviate CSC. Secant we abbreviate SEC. And cotangent COT. Okay. So if we have a triangle, for example, let me just draw a little quick example here for you to reference. Let's say that this side is 6, this side is 8, and this side is 10. We'll call that angle A, there's B, and there's C. So, we could do sine, cosine, and tangent of angle A and B. Let's do some of the new ones here that we're looking at, okay? So we got cosecant, secant, and cotangent. Let's start with secant of angle A. So secant of A, that should be my hypotenuse side over my adjacent side. So for this problem, that would be hypotenuse is 10, adjacent side is 8. So there's your secant side. Okay. How about, let's do cosecant of A. So cosecant, all right, and if you forget, remember cosecant matches up with sine, it's hypotenuse over opposite. So the hypotenuse side is still 10. The opposite side from A is 6. So cosecant of A is 10 over 6. Okay. Let's do cotangent of A. So that one is adjacent over opposite. It's just the tangent flipped. So we're thinking adjacent over opposite. The adjacent side for A is 8. The opposite side is 6. So there we go. Now I know all of these fractions can be reduced down, right? Like 10 over 8 can become 5 over 4. But I really want you guys to make sure you understand the relationships here between the sides. That's the emphasis, okay? Let's do secant of B. So again, hypotenuse over adjacent, just like secant of A was. The hypotenuse side is still 10. The adjacent side to B is 6. Okay? Cosecant of B. Hypotenuse over opposite. So that should be 10 over 8. And then cotangent of B. Adjacent over opposite. So that's going to be 6 over 8. Okay. So that is secant, cosecant, and cotangent. Okay. Another thing you're going to see in these last couple pages on the worksheets are some word problems. And a lot of times when we use word problems in Trig, we're going to use things like ladders or ramps, any kind of real-world situation that models right triangle relationships. So let me do a little word problem here. We'll just call this an example. And you can jot this down. I know we're kind of doing this all in separate paper. If you want to jot this down, great. If not, at least just pay attention to how we draw a picture based on the word problem. So let's say this: a ladder leans against a house at a 62-degree angle with the ground. If the ladder is 12 feet long, how high up on the house does it reach? Okay. Ladder leans against the house at a 62-degree angle with the ground. If the ladder is 12 feet long, how high up on the house does it reach? So let me sketch out a little drawing of this. Say this is our house area. There's our house, yay. House. This is the ground, obviously. Here's some grass. Our ladder is 12 feet long, meaning the hypotenuse of this right triangle is going to be 12. The angle that it makes with the ground means the angle down here. That's going to be 62 degrees. Okay. The question's asking, how high up on the house does it reach? So we're talking about what is the height that it goes up the side of the house. So we can see from this right triangle, we're going to need to relate the opposite side to the angle and the hypotenuse side to the angle. The angle obviously being the 62 degrees down here. So since we're using opposite and hypotenuse, we want sine. So sine of 62 equals opposite over hypotenuse. And so you'll just go through and solve for x. Okay. Trust that you can type that into your calculators. And I'm not super concerned with the answer. I just want to make sure we can set this up right now. Okay. If the question was asking how far away from the house is the base of the ladder, you might be solving for this side. And if that were the case, given the length of the ladder, you would probably want to use cosine to find this side. Okay. So there's that word problem. Hopefully that helps get you started. We'll continue talking about some of this stuff in class, but go ahead and use this stuff, especially the secant, cosecant, and cotangent, to help you with some of those worksheets, okay?